Hello everyone, my name is Ju Wang from the Peter Reiches Institute for Medical Informatics of TU Braunschweig and Hannover Medical School. Now I will be introducing our work entitled with Shackle-based report quality evaluation for health IT-induced medication errors. As we know, medication error is the leading cause of avoidable harm in healthcare systems across the whole world. Health IT systems, for example, EHR, CPOE, or EMRs, can improve medication safety. However, the use of health IT systems itself also potentially introduce new paths to medication errors. To gain knowledge, we need to learn from errors. Therefore, incident reporting is considered a cornerstone for safety and quality improvement, as this reporting can provide a powerful source of information. Meanwhile, we also have to admit that the issues like underreporting or low-quality reporting impede the use of these event reports for efficient signal detection and root cause analysis. There are already some conceptual frameworks available for better understand patient safety events. For example, from a general level, we have the WHO International Classification for Patient Safety, and we also have the Joint Commission Analytic Framework. From a more specific level, to analyze health IT related safety hazards, we have the socio-technical model. And to evaluate the narratives of medication error reports, our colleague also developed the necessary data elements model. All these conceptual frameworks provide a good approach to better understanding and analyze patient safety events. However, a formal ontology representation is still in demand to automate the evaluation process. Therefore, in this work, we developed an ontology representation by applying the shackle to health IT-induced medication errors, and we also used it for evaluating a report quality. Now, let's move on to the methods, how we carried out this work. First, based on the existing conceptual frameworks, we developed the health IT-induced medication error ontology. This ontology is intuitively understandable. It consists of 3 dimensions. The first dimension is contributing factors and hazards. In this dimension, we include health IT factors, human factors, organizational factors, and environmental factors. Because of different contributing factors or hazards, an accident can happen. In the accident dimension, we include the information of a medication and the information of patient and disease. And we also considered the personnel the error is made by or caused by a certain personnel. For the error type, we considered use the NCC-MERP error type classification. After the accident happened, it can cause an outcome or consequence. These outcomes or consequences can have impact on patients or on organizations. Once we have this ontology, we transformed this ontology to a shackle shape graph using the top rate composer. With the ontology, we analyzed and manually annotated a set of medication error reports. These reports were retrieved from the FDA model database based on our previous study. This database collects medical incidents due to the use of medical devices. In total, we analyzed 20 reports and mainly we only focused on the free text. Again, by using top-rate composer, we transformed the annotation to Shako date graphs. Afterwards, we obtained the so-called Shako data graphs using again the top-rate composer. And in the report evaluation stage, we evaluate Shako data graphs against the Shako shape graph. To differentiate the importance of different dimensions in the ontology, we assigned weights to the dimensions. In this preliminary study, for example, we assigned 0.3 to contributing factors and hazards, and we assigned 0.4 to incidence, 0.3 again to outcomes and consequences. We compared the data graphs and analyzed the inter-annotator variation and counted agreement rate, and we computed the quality score of each report for each annotator, and also we calculated the consensus quality for each report by averaging. Now I will show you the results. After we transformed the ontology to Shako shape graphs, we get a shape graph with 38 vertices in line with the ontology. As you can see here, in the high level, we have 3 vertices and 10 vertices on the second layer. And we have 25 vertices on the third layer. All the vertices are connected using the subclass relationship. To zoom in a little bit, you can see here we have the highest level vertices, which are contributing factors and hazards, incident, outcomes, or impact. And later on, in the second layer, we can see the personnel, medication, and error types. The average level of agreement for all reports were 85.3%, with a standard deviation of 7.5%. And the disagreement was mostly frequently observed in contributing factors and hazards, followed by incidents, and finally the outcomes and the consequences. According to our experience, converting a report to the Shako graph took about from 5 to 10 minutes. This will mainly depend on its complexity and the length of the reports. The consensus quality of the reports ranged from 60% to 100, with an average of 87.6%. Okay, finally, we can discuss our work. This work demonstrates the possibility using Shako to represent health IT-induced medication error reports. And I believe this work explored the application of Shako in patient safety event analysis. The agreement of the graphs showed that the variability within inter-annotators was relatively low. Of course, we also observed disagreement, which was in most cases due to the complex or inaccurate report. So, for example, this inaccuracy will lead to a different selection of contributing factors or hazards. The defined quality score allows us to assign an intuitive percentage value to the patient safety report based on this Shako data graph. And after that, this could be automatically calculated. As a first proposal, as a preliminary study, the weights, as I already mentioned, was chosen based on our own experience in this field. Of course, these weights can be redefined for more specific applications. In the next step, we will work forward on automatic conversion of the first text, for example, into the Charcot graphs using natural language processing in the future work. Okay, this is a report of our work, and thanks for your attention. If you have any questions, I will be happy to answer you. You can contact me by email or by phone. Thank you.